Last session we have discussed about memory and memory units and how CPU and memory works whenever it is executing an instruction, how the memory and CPU works. That is what we have seen. In the memory units, how the information will be measured, every information is measured in terms of byte. In that there are different units we have seen bit. Bit is either nothing but it is a binary digits 0 and 1, and also we have seen nibble. Nibble is a 4 such bits. And then byte we have seen 8 bits, right, and then we have seen what word, right, and then also we have seen some of the units and its description. 1 KB is how much? 1 KB is nothing but 1024 bytes. Similarly, 1 megabyte, 1 gigabyte, 1 terabyte, 1 petabyte, all those descriptions units we have seen. And also we have discussed about how exactly CPU and memory works whenever it is trying to execute any particular task or computation, how exactly the CPU and memory works we have seen through by considering the different addresses, and how exactly internally the control unit will take care of sending the information to the input and output, and also to the ALU, how exactly the control unit coordinates all the units. That is what we have seen in the last session. This session will talk about microcontroller. It is similar to, already we have most of the concepts we have discussed in the microprocessor. We will try to understand what is microcontroller, and again what are the types, and how exactly it classified. All those things we will discuss. Microcontroller is again it is a basically IC, it is an integrated circuit that can be programmed. That ICs are programmed for what? To perform a specific or a set of functions. For what? Those set of functions to control a collection of electronic devices. This we call it as microcontroller. A microcontroller is an integrated circuit that can be programmed to perform a set of functions to control a collection of devices, electronic devices. What are the devices? Different devices. We know that we have a memory unit, we have a processor, we have a input output unit, right. So all these will be combined in a single unit, right, a self-contained system in which that self-contained system consists of a processor, memory unit, and also input output, and then all together it is in a single or one package. So all these are programmable is what makes the microcontroller unique. This is how we have seen the typical or we can discuss the different types of microcontrollers. So microcontrollers will be classified into the bits, memory, nothing but the devices, and then the instructions, and then the memory architecture. And also we will see bits means already in the previous memory units concept we have discussed, there is a 4 bits, 8 bit, 16 or 32 bits, even the 64 bit, right. That is one type of microcontroller, even that is also a one of different types with respect to the bits. When you talk about the memory or device, either it is a embedded means it's everything is within, like combined as a single unit, or nothing but it is a external. Maybe sometimes when you talk about memory, yes, there is a primary memory, there is a secondary. Primary memory is which is a part of that system. Secondary, we are just trying to connect the other external device. Maybe that is also one type of this with respect to embedded, and external is another type which comes under memory or device. Instruction set, that is already what we have seen in the microprocessor, the same CISC and RISC instruction. CISC is basically it is a complex instruction set. Here basically the compiler overall, just quickly will summarize, many cycles, and that will make code less. Obviously when the line of code is less, even the compiler has little work, but RISC is one cycle at one execution time is nothing but one cycle. So obviously what happens, it will increase the number of lines of code. Number of lines of in a code, number of lines are more, then obviously the compiler need to do more work, because it has to translate from one language to the another language. So, that is the major difference when you compare to the CISC and RISC. So, reduced instruction set. So, that is with respect to the instruction set, and then the architecture, when you talk about the microcontroller with respect to the architecture, we will try to see how exactly the Princeton and Harvard architecture classification with respect to the memory. And these are the different families like 8051 microcontrollers are available, Motorola is there, PAC is there, Texas is there, National, ARM and others. And these are the different 8051 is Intel and ATML, Dallas, Philips and Siemens. These are the different the family microcontroller family. These are the types with respect to the microcontroller. Now we will try to understand according to the bits. We will try to understand the microcontrollers. In 4-bit, ALU performs arithmetic and logical operations on a nibble, because already the 4-bit, 1 bit is nothing but what is a binary system like 0 and 1. 4-bit is nothing but 1 nibble, that we have seen in the memory unit session. So, here ALU performs its work like arithmetic and logic operations on a nibble. It is nothing but 4 bits in an instruction. Internal bus, it all depends on the sizes, like whether it is a 4, 16 or 32 or 64. Even the bus width also it depends. Here it is a 4-bit, even the bus width is also 4. Bus means it contains, already we discussed, it consists of address, data and overall system, as nothing but the control bus. And obviously, since it is a 4-bit, size is small and pin count is also less, and obviously we have very less count than even the low cost controllers. And another important, low power consumptions and used for low end applications. It will not be useful for higher end applications like LED and LCD display drivers, portable battery chargers, such things. Examples, these are all the examples for 4-bit microcontrollers, Rensa and ATAM series from the Atmel. And similarly, all the operations same with respect to the 8-bit controller also, but here in the previous slide we have seen with respect to the 4 bits, ALU performs with respect to the 4-bit, but here the same arithmetic logic operations with respect to byte format, that is an 8 bits. And now the bus width is 8-bit. Examples for this 8051 family and Motorola. These are the examples for 8-bit microcontroller. And 16-bit same work, only the the size is very 16-bit in an instruction. Bus width also becomes 16-bit, and obviously when you compare to the 4 and 8, even it will performance will be enhanced, and even computing ability will also increases, and precision will be greater precisions when you compare to the 8-bit microcontrollers. Examples for such 16-bit 8096 family, and even Motorola has some series with respect to the 16-bit. Similarly 32, so much more. It is just an enhanced version of 4, 18, 16 and 32. The same ALU, all the operations does the same, ALU does job is same, CU all the same, but only thing is it will be enhanced performance. And now when you talk about embedded and external with respect to the memory or devices, now we will see embedded microcontrollers. Everything is embedded. An embedded system is what? A microcontroller unit that has all the functional block together, or in the same chip. If you talk about a single chip, in a single chip all the blocks, that single block consists of all the functional blocks, including your data memory and your the instructions, nothing but the programs, all will be in a single chip or in a same chip, that is called embedded. So examples for such embedded, 8051 having the program and data memory, even it includes IO ports, communication ports, right, counters, registers, everything will be in a single chip. That is a typical structure. That's how it looks, your embedded microcontroller. Here you can see the ports, here you can see the different parts, input, output, ports, everything. Now external, so you need to plug in plug in that device to this. An external system as a microcontroller unit that does not have all the functional blocks on a single chip. What we have seen in embedded, everything is in same chip, but now we do not have everything in a same chip. So, all are part of the memory. So, different parts. Now, all the parts of the memory units are externally interfaced. You see everything is different here. So, all are just externally, all the memory units are externally interfaced by using the interfacing circuit. That interfacing circuit we call it as a glue circuit. Example for such external, that is a 8031. It has no program memory on the chip. Now, instruction set, already we have discussed complex instruction set computer architecture microcontrollers. So, as an instruction set that supports many addressing modes for an arithmetic and logical instructions, even for the data transfer and memory to access the memory. And many of the instructions are macro, which are very small, allows the programmer to use one instruction in place of many simpler instruction. Instead of many simple instruction, you can use one instruction. Example for such CISC is 8096 of Intel. And the RISC, it contains the instruction that supports the less addressing modes for the arithmetic and logical instructions for data and data transfer instruction, and it will allows the simultaneous access of the program and on the data, and instructions will be pipelining, so increasing the execution speed, and it will allow each instruction to operate on any register or use any addressing modes, and the chip or pin count will be smaller, and with respect to the power consumption, it is very less. According to the memory architecture, these are the two examples. The architectures of any microcontroller that will differ in the way the data and programs which they have stored and how you want to access. First one is van Neumann, we also call it as Princeton architecture. How exactly the microcontroller, the architecture of this Princeton are in the van Neumann. Here it is a single data bus. So, there will be we have seen in the microprocessor there are different buses, address, data and system are the control bus. Now, we will see single data bus that will be used for all, that used for both used to fetch both instructions as well as data. If you want to fetch the instructions, there is no separate bus, and even if you want to data also, for both you need to use the same data bus, and even the program instructions and the data that are stored in the common main memory. There will be a main memory unit. So, there is a separate for instruction and there is a separate for data, but here there is only single bus. Since single bus is only single data bus we are using for both instructions as well as data. Even the programming, the same such programming instructions and the data will be stored in the common main memory. When such controller addresses the main memory, it first always what happens, where first fetches the main memory and then fetches the data, because since it is in the same memory, single common memory. So, obviously first it will fetch the instruction, based on that instruction then it will fetch the data with or to support that instruction. This is the microcontroller, we can say the structure. It simplifies the microcontroller design because only one memory is accessed. This is the structure of your van Neumann architecture. See, we have a ROM, we have a RAM, we have different types of RAM. You have variable and then stack. The program RAM. So, that will see entire all these units will be interacted. It is a two-way communication, data and address, control, data bus, address bus, control bus. So, with the memory that will be, there is a single bus for instruction to decode and with respect to the processor and some of the built-in registers. Now, another architecture is Harvard architecture. Here we have a separate data bus for the instruction and data. Execution occurs parallel, because since we have separate buses, data, separate data bus and even the instruction bus. So, obviously the execution will happen parallel. And when you compare it to the van Neumann architecture, it executes in a faster mode, because it has two separate data and instruction bus. So, even execution will also occur parallelly. Obviously, the execution speed also faster. and obviously when it is parallelism or parallel execution is there, even the design of that the system is also a bit complex when you compare to the one man architecture. Example for this, you can see Intel MCS 51 family and even the PIC microcontrollers. This is how it is designed. There will be a control space, here program RAM, here it is a register space. We have a separate data bus, right. So you can see the data and then the address and then the control. So that will be instruction decoded with respect to the PC stack, and then your processor and register will be there again same. This is one bus, this will be interacted here to the register space. So how exactly internally the operation or the internal operation. The microcontroller consists of thousands of digital circuits that are combined into areas which will provide to specific functions. So the parts of microcontrollers are used for what are the purpose we use for different parts, basically to save the data and even the programs, and to perform the different functions with respect to or whatever the ALU does. It will perform mathematical and logical functions and also to generate the timing signals. So even for that also microcontrollers are used, and different areas are connected by all the components will be connected. We have seen in that how exactly interconnection happened between the different components. In that, during that session we have discussed the same point here. All the different areas are connected by using this bus system. The bus system contains tiny parallel circuits that carry the digital pulse patterns from section to section, and RAM will stores the program required for the microcontroller. So read only memory that will store the program or instructions which are required for the microcontroller to function, and also it controls how the chip components operate and how the data and instructions flow through that chip. And RAM will be store the programs and data temporarily because it's it stores the program, and even the RAM stores the program, but these programs which are required for our microcontrollers to control all. But here RAM which will store the programs and data temporarily. So both ports and registers are special memory locations that will be dedicated to the specific function, maybe such as hardware location or a place of where exactly you want to manipulate the data. So and areas of where exactly these microcontrollers are used are nothing but the applications. Home monitoring system we have used, automotive applications such as robotics, appliances, microwave, oven, refrigerators, TVs, VCRs, stereos, and also in the automobile industries like to control the engine, to diagnose, and even the climate control. I think nowadays if you go to any showroom for the car service, they won't check the each and every part, just through engine, through that microcontroller they will diagnose, just they will insert that device into the your vehicle, and they will start diagnosing your entire the condition of the vehicle. Through that diagnostic system also we have used this microcontrollers, and also to control environmental in greenhouse temperature, humidity, factories and home, everywhere we use this to control the environment, and instrumentation and even the aerospace. These are the some of the topics. From this we are concluding the fundamentals of computers first module. It's the basics or introduction of the computer. Some of the questions I have given here, just to brief what are the basic functions performed by the functions which are performed by the computer, and like this maybe you choose the correct answer. The task of performing arithmetic and logical operation is performed by who will do this arithmetic and logic operations, maybe for your and ILU and CU are jointly known as what we call, and the process of producing results from the data for getting useful information, that we call it as what. So like that kind of questions, both subjective and objective. From this I conclude the first module of fundamentals of computers. Thank you.